अच्छा चले इसमें what was the last thing we did do this we did hydration ठीक है where I told you that you had a gaseous ion and that gaseous ion gets completely surrounded by water. I told you okay, your gaseous ions they form complex ions which are basically the ions datively bonding to the solvent molecules. So this was hydration. And we talked about enthalpy of solution a bit as well. And I told you that it could be both endo and exo. As anyways, we were at figuring out the solubility or thermocycle or Hess cycle of a particular of ionic compounds. So Skanda, I told you okay, there were two steps. One was that you were going to when you try to dissolve, the first thing is you're going to break the ionic lattice. Up here, next part is K. The ions would then attract the water molecules and they would hydrate themselves. Okay, is this clear?
Yes, sir.
Achha, so the cycle is that if you have NaCl solid and you're trying to dissolve it, okay, usko you're trying to make it aqueous, so it dissociates and turns aqueous. Okay, that's enthalpy change of solution. So Na+1 or Cl-1 aqueous aqueous ions are produced. So this one is your enthalpy change of solution. अब इसका दूसरा रूट क्या है या स्टेप वाइज क्या है ठीक है. So you're basically trying to go from this point to this point. मतलब ये ऊपर दो steps बने हुए हैं. So the other route is you're going to break the lattice. So that is going to give you Na+1 and Cl-1 gaseous ions. So that's the first step. Up here, in gaseous ions, you're going to hydrate them. You're going to mix them in water, and they're going to turn into aqueous ions. Okay? So these are your two steps. This is your enthalpy change of hydration. And that one is the negative of lattice energy. Why negative? Because you're trying to break the lattice. Okay? Uske andar. So that's your enthalpy change of solution. Or isko na one path is equal to the other path, so you can write the formula, which is going to be कि your enthalpy of solution is basically, and this is specifically for ionic compounds. So your enthalpy of solution is basically the negative of lattice energy. As in the negative sign just indicates that by definition it's negative. Okay, you're going in the opposite direction. You're breaking the lattice. Okay, plus the enthalpy change of hydration. Is this clear?
Yes.
So then the other thing about this is that it's the other thing about this is okay, the first part is endothermic lattice energy wala, where you're breaking the lattice, okay? So that is endo, and the next part is exo. You're this wale part mein you're breaking the lattice. And in the next part, बल्कि ज़्यादा specific हो जाते हैं, you're breaking the ionic lattice. And the next part is you're forming bonds with water molecules. So the next part के अंदर ions, they form dative bonds with water molecules. So one part is endo, the other part is exo. And this is the reason why enthalpy of solution could be both endo और exo, क्योंकि वो दोनों के साइज के ऊपर डिपेंड करता है. So if your lattice energy is very endothermic, तो इसका मतलब है कि if the lattice is really strong and it requires a lot of energy to break the lattice, so enthalpy of solution is overall going to be endothermic. On the other hand, if the lattice breaks easily and very strong bonds with water are formed, then that would make it very exothermic. Is this clear?
Yes.
Achha, next is I mean one type of question that you're going to get, and let me just give me 1 second. Let's try and do this. I mean, you're going to get questions on this, Tika, on this specific thermocycle. So just 1 second. Let me. Let me open the file. For some reason, my so ठीक है यहाँ पे open हुआ है. So we can right now we can do this over here. So now lattice knee is के ऊपर enthalpy of solution. Let's just wait a second. No idea क्या हो रहा है. 1 second रुको. Downloads. अच्छा वैसे ही खोल गया. चले. बस ठीक है. For example, I just wanted this question, बल्कि इसको I'll just copy paste this question. अच्छा ये जो relevant thermocycle, I'm just copying it here. अच्छा for some reason my laptop has really slowed down. अच्छा ये कर लेते हैं finally there. So he's saying find the enthalpy change of solution. So you would get a question like this. You're supposed to find the enthalpy change of solution of a substance. In this case, he's talking about the enthalpy change of solution of MgOH2. Now, for this, remember, it's important that you draw, although the formula is in front of you, you can apply the formula directly, which is the negative of lattice energy plus enthalpy of hydration. But the only problem is you have to be careful about the moles of substances. For example, MgOH2. Okay, and then if I draw the thermocycle for MgOH2, it's going to look like this. It's going to be MgOH2 solid, and so that's solid, and that would be turning into that would be dissolving. ठीक है, the plus aqueous, and it's going to dissolve and form magnesium ions aqueous plus 2 OH minus 1 ions aqueous. So it's going to do that. So that's your enthalpy change of solution. So you're going from this point and you're going all the way to the other point where you get aqueous ions. So those steps. First one is you would have to break the lattice. Okay, so if you break the lattice, you're going to get a magnesium ion plus you're going to get 2 OH ions. Okay, so you get these two things and then you mix them in water and they turn aqueous. So that's your enthalpy change of hydration, and that is what's happening. So यहाँ के ऊपर you are breaking the lattice. I said now the only thing you have to be careful about this is okay, when you do this, the enthalpy of solution, that's 1 mole. You have to be careful about moles. So you're dissolving 1 mole of a substance, the enthalpy of solution the 1 mole के लिए you're breaking 1 lattice, so that's fine. So ऊपर जाके in the table, I'm just going to look for the lattice energy of magnesium hydroxide. So lattice energy of magnesium hydroxide is given as -2,993. Okay, so that's given as -2,993. लेकिन ये प्लस हो जाएगी क्योंकि it's the negative of lattice energy. Is this clear, Lubana? Is this clear? And then you're hydrating the ions. Now you have to be very careful. Okay, how many ions are you hydrating? You're hydrating. So that's basically delta H hydration of Mg2 plus delta H hydration of OH ions, but that's into 2. ठीक है, so that's going to be multiplied by 2. तो अगर मैं इसमें now if I put in the values, my enthalpy of solution is going to be equal to the negative of lattice energy, which in this case would become plus 2,993, and plus the enthalpy change of hydration, which again, if you look for Mg2 plus, it's what's the value for Mg2 plus? It's minus 1890. Okay, so that's given as minus 1890. And the other is 2 into the hydration of OH ions, and that value is given as minus 550. Okay, so the first column is for magnesium, so minus 550. So we're basically using the same formula, which is the enthalpy of solution is basically equal to the negative of lattice energy plus the enthalpy change of hydration. So it's the same formula, except that you have to be careful about moles. Okay, so Lubena, the only thing left is you would have to calculate this. So can you tell me what the value is? Do you have a calculator with you?
3.
So you're getting plus 3, right?
Yeah.
Kilojoules per mole. Can you also do this for strontium hydroxide, which is going to be pretty much the same thing? It's going to be the same thing. Uh, Try and find it for strontium hydroxide, this one over here. Enthalpy change of solution. What value would you get? I mean, they're in the same group, so it's the same number of moles. The whole cycle would be the same. Try and solve for that as well.
Negative 47.
So for that, you're getting negative 47, right? So, I'm just going to write over here that so our enthalpy of solution for MgOH2 so that one is coming out to be plus 3. And for enthalpy of solution of SrOH2, that's coming out to be negative 47, right? So which one is more soluble? What's happening down the group? Is solubility increasing or decreasing? Based on the values of enthalpy of solution. Which one is more likely to be soluble? Endothermic or exothermic? क्या होगा is are What's your answer?
That one that's more exothermic.
ठीक है, so that means solubility is actually increasing down the group. So your solubility, it increases down the group. Uh, and we all know that for hydroxides, the solubility of in group 2, it increases down the group. Now, a very similar question that usually appears. One of the questions is as simple as this one. Okay, so there's not. I mean, you just need to know what the thermocycle or Hess cycle is. And there's a very typical question that usually often comes. And even in this question, whenever they talk about enthalpy of solution, you usually get this 3 or 4 mark question, which is describe how the solubilities of the sulfates vary down the group. And this question appears a lot. They talk about hydroxides, and at the same time, they also talk about sulfates. So the question is, and this is something that's part of group 2 in A levels. In A levels, you don't really do much of group 2. This is the only, group 2 is not part of your A2 level. Although it's by default a part because you studied that in AS. So you're not going to study much of group 2 in A2. But this is one thing that is related to that. So why does the solubility of group 2 sulfates increase down the group? So the example that we have is that we've got MgSO4, which is soluble, and right at the bottom we have BaSO4, which is quite insoluble. So when you move down the group, the solubility decreases. So the question is, why does it decrease? For that, I'm going to make this thermocycle again. It's going to be MgSO4 solid. You mix it in water and it turns into aquasines. That's just this is enthalpy change of solution, and the other part is you're going to break the lattice, negative of lattice energy, so that they turn into gaseous ions. And then those gaseous ions, they mix in water to form, and that's your enthalpy change of hydration. So that's your complete cycle. So if solubility decreases, that kind of indicates that enthalpy of solution is becoming more endothermic. So overall dissolving becomes more endothermic. It requires energy to dissolve a substance. ठीक है, Lubena, is this part clear as well?
Yes, sir.
So that's the first line when you're trying to answer that. I mean, one is that solubility decreases. That's the first point to the answer. Down the group, and why as enthalpy change delta H solution becomes more endothermic. Or you can write that it becomes less exothermic. Achha, so what's happening down the group? The only thing that's happening down the group is instead of magnesium you've got barium. Uh, Instead of magnesium ions, you've got barium ions. So how is the thermocycle, the Hess cycle, affected by that? Now barium is a bigger ion. What do you think? How would a bigger ion affect the value of the lattice energy and the value of the enthalpy of hydration? Any ideas? Do bigger ions make stronger bonds or weaker bonds?
We could.
So, so down the group, I mean that's our second point, right? It's if you move down the group, cationic radius increases. I mean the anion pretty much remains the same. So down the group, the only difference is when you move down the group, the cat ionic radius increases. So both lattice energy, because weaker bonds are being formed, so the lattice is going to be weaker. Barium sulfate is going to be a weaker lattice. So both lattice energy and even the bonds that are formed with water are going to be weak as well, because bigger ions, they form weaker bonds. So both lattice energy and delta H hydration decrease. TK, is this clear?
Yes.
So both decrease. But I told you that enthalpy of solution is becoming more and more endothermic. Now, one of the terms is endo. I mean, the first one is endo, you're breaking the lattice. And the second term is exo, because you're forming the lattice. Now, if down the group enthalpy of solution is becoming more endo, so relatively, the endo term is going to be bigger than the exo term. Is that clear?
Yes, sir.
So both lattice energy and enthalpy of hydration decreases, but lattice energy decreases less. I mean, it's relatively bigger compared to compared to delta H hydration. ठीक है, so That's your whole explanation for this, which is that when you move down the group, both lattice energy and enthalpy of hydration become smaller and smaller. But enthalpy of solution is the sum of both. So because it's becoming less soluble, that means this part is still relatively bigger compared to this one. So is this clear, the explanation?
Yes, sir.
Achha, so you have to remember this specific explanation. And there's another one which is for hydroxides. Now, hydroxides, it's the opposite. That for hydroxides, the enthalpy of, I mean, they become more soluble down the group. So the only difference is that for hydroxides, uh, the enthalpy of solution is going to become more exothermic. Solubility increases down the group as delta H solution becomes more exothermic. And why? Because down the group, the cationic, so both of them decrease, but this time it's going to be the opposite. Lattice energy, I mean, it should be decreases. One second, I haven't written the complete answer. It's going to be decreases less. So I'm just going to write for hydroxides now. Okay, just a second. And I'm just going to change a few of the keywords. So group 2 hydroxide solubility increases down the group. Why? Because as it becomes more exothermic, and down the group the cationic radius increases, so both lattice energy and enthalpy of hydration decrease. But the lattice, because it's becoming more exothermic, so lattice energy decreases more compared to enthalpy change of hydration. Okay, so is this, are the two explanations clear?
Sir,
Yes,
would the enthalpy change of hydration increase or decrease in hydroxide?
it becomes more exothermic because it's becoming more soluble. Like I can write it over here. One second. Like if you have MgOH2, that's insoluble. So that means enthalpy of solution is kind of endothermic. And if you have barium hydroxides, that is soluble. So this is, so solubility increases down the group. So delta H solution becomes more. It becomes more exothermic. Sorry, यहाँ पे लिखा हुआ है. ठीक है, is this clear?
Yes, sir.
So that was all about group 2 hydroxides and also about group 2 sulfates. And a lot of times you get a very, very typical question on this. If I have the worksheet open, it appears a lot of times. पता नहीं इसमें है कि नहीं. It's अच्छा चलिए ठीक है. I'm sending you this worksheet, this specific worksheet. Try and go through these questions. One second. ये मैं WhatsApp पे भेज रहा हूँ. So ठीक है, I think it's sent on the group. So let me try doing these questions, ठीक है? And we'll do more of these questions later, ठीक है?
ठीक है sure.
चलिए ठीक है. Okay then, take care. Allah Hafiz.
Allah Hafiz.